This is on your formula sheet. What is the formula for z-score? Z-score is always going to be my number that I'm picking, in this case it was 13, minus mu, or the mean, divided by sigma, what the value of the standard deviations are. A z-score indicates the number of standard deviations that a data lies from the mean. A positive z-score indicates that it's above, and a negative z-score indicates that it is below. So, if I put this into a z-score chart using the standard bell curve, approximately 68.3% of the data lies between z-score of -1 and a z-score of +1. 95.4% exists between a z-score of -2 and a z-score of +2, and 99.7% exists between z-score of -3 and a z-score of +3. So if it says the heights in centimeters of 5 starting members of the Wolfhounds basketball team are 170, 182, 193, 195, and 212. If the mean height, or mu, is 190, and the standard deviation, or sigma, is 15, calculate the z-score to the nearest hundredth for the tallest player. The calculation of the z-score for the shortest player is shown. Well, here's the shortest player here, so I'm going to say that if I'm solving for the z-score of the tallest one, 212, then that's going to equal 212 minus 190 divided by 15. The z-score for 212 is going to equal positive 1.47. And we always do our z-scores to the hundredth. Z-scores can be used to compare data from different normal distributions by converting the distributions to the standard normal distribution curve. So, Tony's midterm marks are shown below, together with the class mean and standard deviation for each subject, by calculating z-scores to determine which subject Tony performed best at relative to the class. So we're going to do the z-scores separately. First, we're going to solve for the z-score in math. And we're going to say that Tony's mark in math was 74, minus the average mark was 68, divided by the standard deviation, which was 12. In math, he was 0.5 or 0.50 standard deviations above the class average. In chemistry, he had a 79%. The class average was 73, and the standard deviation was 14. He had a z-score of 0.43, or 0.43 standard deviations above the class average. And lastly, in physics, he had a 68, class average was 66, and standard deviation was 11. In this case, he was 0.18 standard deviations above the class average. So, which did he perform best at? Tony performed the best in math relative to the class average. because that one, even though it was not his highest mark overall, it was the highest standard deviation away from the class average. So it might not have been the mark that he got the highest in, but it was the mark that he did the best in relative to everybody else in his class. For example 5, the average mark on an English exam was 63. There's my mu. And the standard deviation was 12. There's my sigma. If the marks were normally distributed and a student's z-score was 1.5, what was the student's actual mark? This is just rearranging our formula. We're going to say, well, if z is equal to x minus mu over sigma, then I'm going to substitute in the data that I know, and I'm going to say that the z-score, which was 1.5, is going to equal x, I don't know what the student's mark was, minus the average, 63, divided by the standard deviation of 12. I'm going to multiply both sides by 12 and say that 18 is equal to x minus 63, and then I'm going to add 63 to both sides. 81 was equal to x. The student's mark was 81%. The weights of a large shipment of cantaloupes are normally distributed with a mean of 2.3 kilograms. There's my mu. The weight of a particular cantaloupe is 1.7 kilograms. There's my x, which is 1.01 standard deviations below the mean weight, which means my z-score is going to be negative 1.01 because it's below the mean weight. What is the standard deviation? Same as last time. In this case, we're just going to drop in what we know. The z-score is negative 1.01 is equal to 1.7 minus 2.3 divided by sigma, and sigma is what we're solving in this case. Negative 1.01 is going to equal negative 0.6 over sigma. I'm going to multiply both sides by sigma to get out of there. Negative 1.01 sigma is equal to negative 0.6, and then I'm going to divide both sides by negative 1.01. Sigma is equal to 0.59. The marks on math exam of university were found to have a mean of 52 with a standard deviation of 12. A professor thought the exam was too difficult, decided to adjust the original marks by raising the mean to 65 while reducing the standard deviation to 10 and leaving the z-score unchanged. What would the new mark be for a student who received a mark of 34? Well, first, we need to solve what the z-score was for his mark originally. So the z-score at 34 was equal to 34 minus 52 divided by 12. His original z-score was negative 1.50. Now it says that he wants to change the mean and the standard deviation but keep the z-score the same. So I can say that the z-score is going to be the same, negative 1.50. The mu is going to become 65, and sigma is going to become 10, and I want to see what his new mark would be. So, negative 15 is going to equal x minus 65. 50 is going to equal x. The student's new mark is 50% on the test.